Imagine a time when the universe was completely dark. No stars, no planets, no galaxies. Just endless darkness filled with the invisible gas. How did this dark transform into a glittering cosmos we see today? How were the stars born? In today's video, we'll explore how stars came into existence from Big Bang to the first galaxy. Let's start this fascinating journey into history of the universe. 13.8 billion years ago, the Big Bang set the universe in the motion. For the first few 100,000 years, it was in chaos. The universe was extremely hot and dense, so much that no atoms could form. As the universe expanded, it cooled. About 380,000 years after the Big Bang, temperature dropped enough for protons and electrons to combine, forming the first atoms, hydrogen and the helium. This period is called the recombination. The universe became neutral and the light was finally able to travel freely. But this light didn't last long, and the universe plugged into darkness again. Scientists call this as the cosmic dark ages. During this time, hydrogen and helium atoms floated freely, along with something mysterious called dark matter. This was the raw material needed to form everything: stars, galaxies, and eventually planets like Earth. To understand how stars were born, we must first talk about the gravity. Einstein's general theory of relativity tells us that anything with mass wraps space-time. Even tiny particles like hydrogen atoms exert gravity, and the dark matter, though it's invisible, added even more mass. Over time, gravity started pulling hydrogen and the helium atoms together into the dense regions. From about 150 million years to 1 billion years after these atoms began to accumulate, forming massive clouds of gas. These clouds, called the nebulae, were huge, some over a light year across. At this stage, a battle began inside these gas clouds: gravity versus pressure. Gravity pulled the gas inward, trying to collapse the cloud. At the same time, the motion of atoms created pressure that pushed outside, trying to stop the collapse. If the cloud was big enough, about a certain limit called the Jean's mass, gravity won. The cloud started to collapse. As the gas cloud collapsed, it started spinning. But why? Because any slight rotation in the cloud was amplified as it shrank. This is due to the conservation of angular momentum. Because the collapsing cloud was spinning faster and faster. This spinning flattened the gas cloud into a disk shape, with most of the mass falling towards the center. As matter was squeezed together, temperature began to rise. At this stage, atoms collided with incredible force, and the gas turned into a plasma. Plasma is a hot, energetic state where electrons are stripped from the atoms. At the center of the spinning disk, a dense hot core formed. This was the protostar. A protostar isn't a star yet. It's a hydrostatic equilibrium where the outward pressure of heat temporarily balances inward pull of gravity. As the protostar continued to pull in more gas, its core grew more hotter and denser. The temperature eventually reached millions of degrees, hot enough for a nuclear fusion to begin. But what is fusion? At these extreme temperatures, hydrogen atoms collide with such a force that they fuse together to form helium, releasing enormous amount of energy. This energy generates intense heat and light, which pushes outward and prevents the star from collapsing further. And just like that, a star is born. The first stars in the universe light up the darkness, ending the cosmic dark ages. These stars were massive, much larger than most stars we see today, and they burned their fuel quickly, living short but brilliant lives. The birth of stars did more than just lighting up the universe. The powerful radiation from these early stars caused surrounding gas to reionize, stripping electrons from the nearby atoms. This period is called the epoch of reionization. At the same time, stars began to group together, pulled by gravity, to form the first galaxies. Some were small, with few hundred million stars. Others grew to hundreds of billions of stars, becoming the giant of the cosmos. These galaxies did not exist in isolation. Over time, they clustered together to form the larger structures, galaxy clusters and the superclusters. These structures are the building block of the universe as we know it today. By the end of this billion-year period, the universe looked much more familiar. Stars were burning brightly, galaxies were forming, and the cosmic structures began to take shape. But stars did not just light up the universe. They were also the factories producing heavier elements like carbon, oxygen, and the iron through fusion. These elements are essential for the formation of planets and eventually life itself. However, the story doesn't end here. How did planets form? And what happens when the star dies? To answer that, we need to explore the life cycles of the stars, which we'll cover in our next video. The birth of the universe transferred the universe from dark, empty void into the dazzling cosmos we see today. It all started with the gravity, pulling atoms together to ignite the first stars, which became the seeds of the galaxies, planets, and everything we know. If you enjoyed this journey through space, don't forget to like, share, and subscribe to Space Albatross. Let me know in the comments what part of star formation process amazed you the most. Stay curious, and I'll see you in the next video.